Okay, in this video we're going to talk about a different type of sequences, so arithmetic sequences or arithmetic sequences. Okay, so a sequence where the difference between the consecutive numbers is constant, so we're going to be either adding or subtracting things to get from one number to the next. Okay, so we have our recursive formula, so that's when we care about the term before it. Ooh. That was really bad. Before it. And then explicit, whenever we have our n here, we just plop them in and solve it. Okay, D in this situation is going to stand for, we're going to call it distance. Okay, so the distance from one to the next, what's being done. So is the sequence arithmetic, then write the recursive formula if it is. Okay, so they need to be either adding or subtracting by a constant for it to be arithmetic. Okay, so in this situation, you can see that we're adding 3 each time. Okay, so the distance is going to be 3. My a sub 1, or my first term, is going to be 3. So when we write our sequence, recursive, remember, is the one we care about what's happening before it, and then what we're doing from that term to the next one. Okay, so a sub n equals a sub n minus 1. That means it's recursive, and we're adding 3 to each term to get to the next one. If I look at this one, we're adding 3, adding 5, adding 7. It's not constant, so it is not arithmetic. It has to be a constant for it to work. Okay, this one, it looks like we're adding 4, adding 4, adding 4. Okay, so our D is 4 this time. My a sub 1 is 1. That means my first term. My general recursive equation is a sub n minus 1. We're adding 4 each time. So if I was trying to find the next term, I would add 4. Okay, what is the 100th term of the arithmetic sequence that begins 611? I don't know what 99 is, so I'm not using recursive. I want to use explicit. Okay, so my a sub 1 is 6. What I'm doing from term to term is I am adding 5. And I want to find the 100th term, so a sub 100. That's what I'm trying to find. That's a question mark. Okay, so I'm trying to find a sub 100, so I'm going to plug it into my explicit equation because I don't know what's occurring before 100. I don't know 99. Okay, so if I go back, I'm using the explicit one. So a sub 1 plus n minus 1 times d. So my a sub 1 is 6 plus my n, remember this is replacing because it's a sub n, so 100 minus 1 times that constant that I'm moving by, which is 5. So a sub 100 equals 6 plus 99 times 5. Okay, so 99 times 5 gets me 495, and when I add 6 to it, I get 501. So if I kept that going, I would get to 501 for the 100th term. I think there was another one on here we were trying to find. Okay, nope, we're good. So my next one then, what are the second and third terms of the arithmetic sequence? So this one, I know my a sub 1 is 100. I know the fourth term is going to be 82. I don't know the rate or the distance from this to this and this to this. So I'm trying to find, I need to get the distance to be able to find those. Okay, so if I don't know what's happening before 82, I can't use recursive, I have to use explicit. So it's the a sub n equals a sub 1 plus n minus 1 times d. Okay, so I know my a sub 4 here. I don't want to plug in a sub 1 because then I have it occurring twice and that doesn't make sense. Then I have my a sub 1 representing 100. My n is being replaced with that 4. Okay, right now I still have a sub 4 and d. I can't solve for either of them because I have two variables, but I know my a sub 4 should represent 82. So I'm just plugging in all of my known things so I can find that distance from term to term to be able to find my missing information. So when I solve these, I could subtract 100 and get negative 18. 4 minus 1 should get me 3 there, so I have to divide by 3. So the distance is negative 3 each time. So that means I am subtracting 3 to get to my next one. So 97, oh, 6, sorry. This is 6. Oop. So I'm subtracting 6 to get from one term to the next. So that means this would be 94, and then my next one would be 88, and then 82. Okay, arithmetic mean. So if I'm just missing 1, we could do it the long way where you represent your a sub 1 and your a sub 3 and plugging and chugging, or we can use this simple equation where we take the average. Because we're adding and subtracting to get from one term to the next, we can take the average. If we're multiplying, it's completely different. Okay, so adding and subtracting, for these would take 15 plus 59 and divide it by 2. So 15 plus 59 gets me 74. Divide that by 2 and I get 37 right there. Or you could do it the route that we just did it to double check to make sure. Okay, so find the 43rd term. So my a sub 1 is 12. It looks like I'm increasing by 2 each time, and I'm trying to find a sub 43. So I don't know what 42 is, so I need to use the explicit formula. So I got a sub 43 equals my a sub 1 this time is 12 plus my n is 43, and my distance is 2. So we're just going to simplify this. So 12 plus 42 times 2, I'm going to type that all in my calculator. So 12 plus 42 times 2 is 96. So if I kept that going, my 43rd term would be 96. Okay, this one, it looks like I'm subtracting 6 each time. So my a sub 1 is 21. I'm trying to find a sub 43, or the 43rd term, and my distance this time is negative 6. So a sub 43 equals my a sub 1 this time is 21 plus my n is 43 and my d this time is negative 6. So we're multiplying by negative 6. So a sub 43 equals 21 plus 42 times negative 6. So 21 plus 42 times negative 6. My 43rd term this time would be negative 231. Okay, find the 18th term. So I'm going from 17 to 18, and my distance is 3. So technically, if I'm just going from one term to the next, all I have to really do to get my 18th is add 3. If you want to do it the long way, I'm trying to find a sub 18. So I have a sub 18. I know the term before it, so I'm actually going to use recursive in this situation. So a sub n minus 1, well, my n represents 18 this time. And then the distance this time is traveling is 3. So I'm going to simplify 18 minus 1 gets me 17, and I know my a sub 17 represents 6. So 6 plus 3 would then get me that same 9. So you can do it this way and still get the same thing since you know it's before it. You just have to plop it into the recursive formula, not the explicit. Okay, my next one, I'm going to 18 again, so this time I need to subtract 3 to get to my next one because the distance is negative 3, so I should get negative 5. And my last one, I go from 19, I need to go backwards. So instead of adding 2 to get to my next one, I need to subtract 2 to get to the one before it. So this one is actually going to be 8.